And now a message from the inside of Richard Saunders' walk-in refrigerator.
The Skeptic Zone, a miracle of technology. A universe of reason, the Skeptic Zone.
Hello and welcome to the Skeptic Zone, episode number 63 for the 1st of January 2010. Another year of the Skeptic Zone and the year of TAM Australia in November. More about that all through the year. It's Richard Saunders here with you once again. On today's episode, we have a recording from last year's Dragon Con with our good friend and reporter Kylie Sturgess, Psychology and Skepticism in the Classroom. A fascinating panel. And after that, we've got a couple of gems from the late 80s and the early 90s. We have a talk from the 1988 Australian Skeptics Convention about crystal power and pyramid power. It's very interesting to hear what they thought way back then, over 20 years ago, about crystal power and pyramid power. That's followed by a, discussion between Magda Palmer, crystal healer, and Professor Ian Plimer, geologist, recorded, the best guess I can make it is about 1992 or something like that. And they have a very frank discussion on the power of crystals, the magic power of crystals. So sit back, have a nice cool glass of lemonade, and enjoy this episode of The Skeptic Zone.
I'm Kylie Sturgess, and at DragonCon in 2009, several panels which focused on the communication and teaching of skepticism were presented, one of which I moderated. It was called Skepticism, Psychology and in the Classroom. It was designed to highlight the contributions of teachers from high school to university level, including outreach efforts across those years. Leading skeptics who took part included Australia's Dr. Martin Bridgstock, whose book Beyond Belief was launched at the Australian Skeptics National Convention in Brisbane. At the time, DJ Grothe was a program director at the Centre for Inquiry and podcast host for Point of Inquiry. He's now the president of the James Randi Educational Foundation. Finally, there's also Barbara Drescher and Matt Lowry and myself, all members of the Critical Thinking Education Group.
Thank you very much, Derek. Welcome to Skeptical Psychology and in the Classroom. Originally, we had the idea of making this two separate panels, one looking at skepticism and psychology and then looking at skepticism in the classroom. And then we realised that the combined talents and experiences of the people who are here with us today bring quite a lot of both of those disciplines together. Not all of us are high school teachers or primary school teachers. Education takes many different forms. Outreach is a very popular thing, I know, amongst skepticism. I'm certain I can see already that there's people from a variety of backgrounds. Maybe some might be from psychology, some might be from education, and I'm certain that there's a lot of parents out there. And stakeholders come from many different places, and here are some of the stakeholders. Please introduce yourselves. My name is Kylie Sturgess. I'm a research assistant at Curtin University in an education department. I was a high school teacher for 10 years, and I'm currently doing my second MEd. My first was in gifted and talented education. My second focuses on paranormal beliefs and the educational measurement of them.
I'm DJ Grothe with the Center for Inquiry, which is a science advocacy and educational organization at the State University of New York. CFI runs the only kind of skepticism science education master's degree, science in the public in the United States through the State University of New York. CFI, through its campus outreach program and its youth education kind of skepticism teenage summer camp thing, and I think that's a trademarked description. We are really invested in spending our resources to advance the critical rationalist, the skeptical point of view among college students, high schoolers, and teenagers, not just to those of us who feel like we're a besieged minority who want to get together and talk about another reason why ghosts don't exist. So we're reaching out, as Kylie mentioned, to kind of all these various publics, especially college students, with now about 200 campus groups on colleges across throughout North America, even in Australia, Europe, England, to be sure. So that's me.
Hi, my name is Lowry. I'm pretty deep in the trenches. I'm a high school and college level physics and astronomy instructor. I teach in Northern Illinois, and I've been getting more and more involved in the skeptical movement by connecting with people like Kylie and DJ and Barbara and Martin. And one of the things that I've been involved in recent years, besides just generally trying to gel skepticism in education and working with people like these, is working on grassroots skepticism. If you were at the Darwin's Bulldogs panel yesterday, you'll know that one of the things that I've done is in Northern Illinois, I started a grassroots, I guess you could call it skeptical organization called Darwin's Bulldogs, which challenges creationists when they attempt to come into our area and push their nonsense. And we also advocate for good science education. So my effort is more localized than anything. However, if you're interested in reading any of my musings on these and other matters, I'll give myself a shameless plug for my blog. It's a Skeptical Teacher. Just Google Skeptical Teacher and it's the top hit. And that's me.
Hi, my name is Barbara Drescher, and I teach cognitive psychology to undergraduates at CSU Northridge. I also teach the core science courses like statistics and research methods, the things that a lot of undergraduates are surprised they end up having to take, that it's actually a science. So I kind of have a unique challenge in opening their eyes to whether or not they actually want this major. And reteaching what cognitive psychology is, because it isn't clinical or counseling. It's about learning, memory, decision-making, perception. So one of the things that I've become passionate about, probably mostly as a result of teaching, is finding out more about critical thinking, which, thank goodness, it's in my field. So I've actually kind of shifted my research interests more toward critical thinking, what makes us better critical thinkers, because intelligence is certainly not all of it. I think open-mindedness is better. Is a key component to that. And so in the classroom, I really try my best to shake them up and to show them that what they see of the world, or what they think they're seeing of the world, is not necessarily what the world is to start with. And so we really need to look outside of ourselves and set aside our biases if we want to make optimal decisions. And that's kind of how I approach it as a parent as well. I have two just amazing boys that one's starting middle school, scary, and that has also kind of sparked my interest in, okay, how early can we start this, and shouldn't we be doing it all along? Instead of teaching these children, the no child left behind act, I think is part of the problem. Instead of teaching them what to think, teaching and telling them what to think, we should be teaching them how to think.
Okay, my name's Martin Bridgstock.
Close enough. Nice and close to it.
Close up, okay.
That's better.
Okay, can you hear me? Okay, yeah. Right. My name's Martin Bridgstock. I teach a course at Griffith University called Skepticism, Science and the Paranormal. I have been an academic for 30-odd years. I've been an active skeptic for about 25 years. And this is a full 4-credit course within the university called Skepticism, Science and the Paranormal. It counts within a major and a minor in the School of Science, and it is taken by a range of students from across the university. I've been doing it now for 7 years. They keep throwing awards at me for the course. It seems to go very well indeed. The reaction of the students is like nothing else I've come across in any other course ever, and it's generally counted as a success. If anyone's interested, I can give you more details.
And I think we all do quite a lot of things, don't we? What are some of the things that we feel particularly passionate about and think that really work in terms of getting a bit of critical thinking out there? And, here's a better question. Is critical thinking and skepticism the same thing?
They're continuous, but they're not identical. You could be a critical thinking literary critic or, art history or... and skepticism, as you'll remember the debates, a couple panel sessions a couple days ago, I like imagining that skepticism as an organized movement limits itself, contra maybe what Michael Shermer or Paul Kurtz have argued recently, limits itself to things that the skeptic movement has traditionally focused on. So ghosts and UFOs, etc., because if you broaden the field so widely that it includes every area of human endeavor, then the skeptical movement is, should I say, merely a critical thinking movement, and how do you distinguish that from all the other science advocacy organizations and kind of public interest organizations out there? So in that respect, I think they're continuous, but they're not identical.
I think Martin has a response.
Yeah, I agree with DJ, but I essentially regard skepticism as being critical thinking applied to paranormal topics. So my course is focused on the paranormal. I talk about the way the skeptics think, skeptical principles. Then I broaden them, after we've had a go at astrology and the Amityville horror and creation science and a few other things, then I broaden the course to non-paranormal claims which are controversial. And the two I focus on in particular are the theory that the Apollo moon missions were a hoax. You can look at, well, what is the evidence that they're a hoax, and also Holocaust denial. And so I don't go any wider than that. But I often do find the students write to me completely spontaneously after the course is over and say, after the course, I feel more critical about things generally. I'm less likely to take politicians' pronouncements at face value, for example. So although the course is focused pretty much, there is this definite spillover that students are encouraged to take this way of thinking and to apply it to other areas as well.
I think DJ and Martin's comments are pretty spot on about this. I kind of view skepticism, the skeptical movement, as sort of a subset of critical thinking, if you will. Because as a teacher, I try to teach my students to think critically all the time, whether it's about physics or astronomy, mathematics, whatever. I'm no longer surprised when this happens, but I'm still disappointed when it happens. And I usually have a little baseball moment. When I give an exam, for example, and students come up a day or so later and they say, well, that was a really tough exam. I wasn't expecting questions to be worded like that. What were you expecting? Were you expecting simple like cut and paste type things versus of what you'd seen in homework problems before? Well, yeah. Well, I'm not looking for that. I'm looking for you to think critically, to go beyond what is. I don't want you to be cookie cutter, and that's part of critical thinking. When you put the students into a sort of a mentally uncomfortable position where they have to step up their game themselves, so that is critical thinking. And I think it's wise not to confuse the two, critical thinking and skepticism, along those lines.
What are some of the challenges that we faced? And this is specifically as educators or outreach people. What are some, certainly in our own personal life, everyone's grimacing and starting to roll their eyes. Certainly in our own personal lives, we face things, and sometimes it trickles over, doesn't it? What's the big ones?
I actually, what Matt said sparked something that I see all the time. The students email me and ask me, what should I focus on? And I know that there are faculty members out there who will simply say, well, everything's everything's going to be tested. We all really hate that student who raises their hand and says, is this going to be on the test? But the thing is, I actually give them learning objectives, and many times they are worded exactly as they are in the exam, and they are still surprised. So I think that there is, we become a little complacent, and I think students have become a little, they've gotten used to the multiple choice test. They've gotten used to being told what the answer is and trying to memorize that, not really putting it together themselves. They want to know where in the book is this answer. And at the level that I teach, which is upper division college courses, there isn't an answer. There isn't one answer. It is, you've got this information, let's put them together and draw a conclusion. And being told that they actually have to think about it and form some kind of a conclusion that isn't just based on their gut feeling or what they want to be true is probably the biggest challenge I face. They don't want to do it.
Martin had one, then
Okay, yeah. Let me start from a personal opinion of mine. One of the most disgusting characters that you see on university campuses, not quite the most disgusting, but one of the most disgusting, is the academic who has strong opinions, who pushes those opinions into all of the text and the presentations in their course, and gives you to understand that unless you regurgitate those opinions in the assessment, your grades are going to suffer badly. Now, I think that's contemptible. So what I do in my course is straight from the outset, and I did this right from the start. To my surprise, it turned out to be dead right. I say that what people believe is their own business. I mean, these are young adults I'm teaching, and if there's one thing they hate, it's being told what to believe. So what I say is, what you believe is your own business. It will not affect the marks, but you must grasp these skeptical principles, which I am going to impart, or some equivalents. There's several different ways of doing it, and you must know how to apply them. Then what opinions you have at the end of the course are completely your own business. As a result, this course has run for 7 years now. The second year I ran the course, a fervent advocate of alternative medicine got the top mark in the whole year. Fair enough, he understood the principles, he'd done very well. Last year I had even more of a shock. This was 2008. The top student in the course, gaining 95%, was not only a devout Christian, but I even think she was a creationist. But the fact is, she had been able to deploy these intellectual tools and use them in such a way that her actual performance in the classroom was absolutely brilliant. Now, having said that, I also discovered there's a slight trick here, because although I present these as intellectual tools, they're not like a chisel and a hammer where you can put them away in a box. They're more like a pair of glasses. And once you put them on, you see the world in a whole new way. So normally students, once they've seen the world in this new way, they're irrevocably affected by it. But no, I say this and I mean it and I do it. I don't care what the students' beliefs are. So that's one way in which I get around this very real challenge of being the nasty old man on campus who pushes his own views all the time.
I wanted to dovetail off a couple of comments here. First of all, the whole question about students simply wanting to be able to memorize facts and regurgitate them, so that's problematic. I'm not really sure how you fight that. I think part of the problem with that is, I think part of the onus is on us as educators, the educational community. I think we have gotten to a place where we have allowed that sort of thing to happen too much. I'm certainly the squeaky wheel in my department about something like that. I've been constantly challenging my colleagues, and I'm sure they say nasty things behind my back as a result, but so be it. But as to Martin's point, I do something very similar, because as a physics and astronomy guy, when I teach, I always at some point talk about Big Bang, cosmic evolution, cosmology, all of these really huge concepts and stuff. And I preface it. I say right at the beginning, before we even get into this, I say, look, this is a science classroom. This isn't theology. This isn't philosophy. If that's what you're looking for, you've got to go to a different class down the hall. And that's and I acknowledge this. There may be some people in the room who have a certain religious or philosophical worldview that is going to conflict with the science that I'm going to teach you. And if that's you, then I leave it up to you to reconcile the situation. I tell them flat out, and it doesn't matter if they're high school or college students, I say, I will assume that you're mature enough to figure this out for yourself. And that's it, because I'm not here to teach you what to believe or not believe in your religion or God or whatever. I'm going to teach you science, and that's the end of it. And that's a really good approach, I think, because what that does is first of all, it faces that issue right up front. It's very straightforward. It's very honest. and it puts the onus on the students. It makes them think about it, and if they then want to say anything, they have to articulate what they're going to say. And I think it's a very positive way to approach it. Ironically, one of the first times I did this, 5 minutes later, a student revealed themselves as a creationist, not by saying I was a creationist, but they revealed themselves like I was a creationist by the way they worded their questions. And the rest of the class got pissed off at them because they were like, they turning to this guy and saying, "Didn't you just hear what he said?" And he may not have gotten it, but everybody else in the room got it. So that was a win for me. So there you go.
I'd like to contrast what I do at the Center for Inquiry with what bona fide educators do in their classrooms. So CFI and its component organization, SciCop, now it's the Committee for Skeptical Inquiry, and the Council for Secular Humanism, we are push groups. We're advocacy organizations seeking to advance a mind view or worldview among various publics. So we're, for lack of a better term, and I'm sure I would never want to be quoted or should ever say anything like this from a dais, but we're about propagandizing. We are pushing a point of view. We want to engage cultural competitors. And when Kylie asked, what's the biggest challenge we face? Well, guess what? It's the cultural competition. So there are well-organized forces that, in my opinion, are seeking to undermine the noble tradition of the university, which is something we can all get behind. It's this critical thinking mission, free, unfettered, critical inquiry into every area, and there are groups out there that say, no, that's not the goal of the university. You should go to the university instead to become a better Christian, say. And I don't want to only pick on Christians because that's maybe one component, the skepticism of religion that the Center for Inquiry does. But by way of example, at Middle Tennessee State University a couple of years ago, Center for Inquiry sponsored an event. We do hundreds of events every year at college campuses all over, often sponsored by college professors who bring us in or campus groups that work with us. And this event wasn't skepticism of UFOs or skepticism of Bigfoot. It was about the historicity of Jesus. We think that that's also something one of our component organizations look into, Council for Secular Humanism. And it was a series of events over a week. This event, the program that we put on, featuring Gerd Ludemann, a Bible scholar from Germany, and it created such a ruckus in the local community that the evangelical Christian churches published op-eds and the off-campus papers and stuff actually listing college professors who worked with us to bring that event and encouraging their students not to take classes from those teachers because they said, if you do, it will undermine your faith. Now, we were really gratified that the editorial board of the student newspaper at NTSU wrote an op-ed that we could not have written better ourselves. These kids who wrote the op-ed said, look, you should take at least one course while at school that challenges your convictions. And if you don't, if you're not taking a course that makes you question what you believe, then you're not getting your money's worth out of university. So that's where we see the university. I'm not as against... now, I understand why educators want to avoid the appearance of having a bias, and you hear the religious right often say, oh, you guys are indoctrinating, you're indoctrinating. But at least let's indoctrinate in questioning, not in the answers. We want everyone to say all questions should be on the table, nothing should be off limits. And that is an agenda that, from my non-educator perspective, I think is something all educators should really get behind, rather than, I have some educator friends who really pussyfoot around the idea saying, oh, no, I don't even want to tell you what my beliefs are. I just want to talk about the history of the idea or whatever. And I say, no, come on, we're human beings with beliefs, and I'm all about sharing it and even trying to advance a point of view.
Oh, don't get me wrong, DJ. In the context of the science classroom, I have absolutely no problem calling bullshit. And I've done that on multiple occasions. I've even used that exact word. I usually do it later in the year after it's better. But yeah, I mean, one of the perfect examples is I have a lesson I do on cell phone hysteria. It's going to give us brain cancer, melting, right? And it's a perfect physics lesson, and I have a great time doing it, and I do it in a humorous vein. I actually use a clip or two from Ben Teller's show on the matter. And by the end, the kids are like, "Oh, wow, that's pretty cool." But the greatest irony, one time one of my students walked up to me just last year after I did this, and he said, Mr. Lowry, this is really awesome, but I have a friend that really needs to hear this because she thinks that cell phones are going to give you cancer, so she won't use a cell phone, but she goes to the tanning bed 3 days a week.
Actually, as you were talking, DJ, about telling students that they need to challenge their ideas, it occurred to me that I think I understand the resistance there. I understand, meaning I kind of understand where they're going, not really getting into their frame of mind, because frankly, I am beyond that. It's the falsification approach. When you challenge your own ideas, you are attempting to falsify them. And to people who do that every day, it's very, very difficult for me to understand why, in the case of faith, for example, why challenging your faith is so scary, because it should make it stronger if it's the right thing, right? But that is a scary idea, and it is our way of doing things. So in a way, we're not just asking them to accept critical thinking and accept the scientific approach. We're actually telling them how to do it in a scientific way. I'm not sure what the answer is there.
Possibly the challenge, just to touch on it before I move on to the last point, the challenge I think I continually feel is, am I doing this right? Am I getting in touch with people out there? Am I doing the right thing by scientists? Because I'm not a scientist, I'm an educator.
You're a scientist.
I have... No, I graduated as an English teacher, ESL, and media.
Okay, I take it back.
Thank you very much. And now, good night. Yes.
That's somebody else's label.
Yeah, but I majored in English literature and philosophy. I ended up with a master's degree in gifted and talented education because I was interested in it, and a lot of psychology ended up in that, and I could see how many of the challenges that face students from both ends of the spectrum. And that eventually led me to study for my second master's degree with someone who was a specialist in critical thinking education. She eventually left the department, and so I was left without a supervisor. And that ended up leading towards being more about educational measurement. And so that's another thing, I guess, that worries me. Resources, making sure that I'm touching base with people, that I'm not setting a poor example, that I'm able to network with teachers in my other departments. I was continually running down to the science department whenever I did do skepticism projects. I told everyone everything that I was doing, including the deputy principal, who I knew had very strong Christian beliefs, and she was the first one who immediately whipped around and said, "Oh, you could do that one where you can get an expensive hand lotion, put it on one hand and not the other, and then go around the playground and see if anyone recognises that. Yes, this is Mum's $200 worth bottle of goo, and yeah, and this is nothing, and yet there's no difference." And that was incredibly heartening, and yet I still had opposition in many places, and from many different fronts as well. I guess it's a matter of hoping that A, it's going to work, B, that I'm not going to step on anyone's toes so bad that I damage any possible benefit that I might bring, that eventually, like Martin's course that he says has been looked over and considered and regarded as extremely efficacious, what I'm doing is actually going to work or contribute in some way.
Kylie, your story about your department chair with the hand lotion jogged a thought in my head that I think is maybe worth noting. One of the neat things about the whole broad idea of critical thinking is there's so many things that fall under this, that whether you're dealing with somebody who is, say, a hardcore fundamentalist Christian or a staunch atheist or somewhere in between, transcendental meditationist or whatever, you can usually find something that you can relate to them. Okay. For example, I have in-laws who are, for lack of a better term, they're basically creationists. However, I can get them to think critically about psychic claims, about UFOs, and over the years, I've seen how that kind of insistence on thinking critically about one set of claims can sort of creep over into claims that maybe they hold a little more dearly. I'm not saying they're going to turn into James Randi overnight, but it's progress. You can actually see it happening, but it's usually a very long and involved effort with things like that. But just to kind of throw that out there's usually something that you can find, that you can relate to specific people about in order to get them to think critically in a broader sense. So just wanted to toss that out there.
Okay, I've got one more question before if people would like to ask questions themselves from the audience. Is there hope?
Yes. There are those few students. Certainly for me, especially since I started teaching statistics, there's a huge portion of my class that would really like to burn me in effigy at the end of the semester. And they launch campaigns on, screwmyprofessors.com and so forth. But there are those students that, put you up on a pedestal, not because we deserve it necessarily, but because we were the first ones to show them that there's another way to think, or that there are people out in the world that think in the same way that they do. And that's a big one. Some of these students already have critical thinking skills. They just don't know how to apply them because they've never been faced with others that think that way.
Oh yes, there's definitely hope. The impact that this course, I wasn't aware when I began this course that it was going to have the kind of impact that it has. And I call the impact skeptical shock. And the first example I saw of it was about 6 weeks into the first delivery of the course. And I was so concerned with keeping the course going that I didn't really notice the impact it was having on the students. And there was a student in that first class who was about my age. He was a mature student. And he gave his seminar about 6 weeks into the course. And his seminar was on the Roswell crash saucer controversy. And he analysed what evidence there was and came to the conclusion that there wasn't sufficient evidence to conclude that in fact there had been a crashed UFO at Roswell. Okay, fine, very good paper, he got a very good mark, top grade. And then afterwards, just we were sitting at the end of the seminar, just chatting in the class, he said, "You don't realise what this course is doing to me. I'm having to rethink 40 years of belief." And I get this again and again. In one of the evaluation forms last year, a student wrote in big letters, completely anonymously, "Martin, you destroyed my fantasy world." I intend to do this, but a lot of the students, once they get the idea of these skeptical principles and how they work, they do find themselves looking at the world in a different way, and they recognise the sheer intellectual power of the skeptical approach. They really do appreciate it. Not all of them, but every year it does happen. You bet there's hope.
Yeah, I completely agree. There is, boy, folks, there is bucket loads of hope out there. And I say that for multiple reasons. One, in my own personal experience. There was a time many years ago when I, both as an educator and a scientist and whatnot, I was beginning to get very, very cynical about things. And then I realized that there was this burgeoning sort of awakening skepticism and critical thinking movement, and I got hooked into it. And I started to take what I could and apply these lessons in my classroom. And to see how some of the students would react was very pleasing. And to see how their parents and my colleagues reacted to this sort of thing too was also extremely fulfilling and full of promise. But there's another reason why there's cause to hope, folks. Look around you right now. Okay, we're at DragonCon. Okay. We're at which is cool, by the way. We're at a science fiction and fantasy convention, probably one of the biggest ones in the United States every year, right? And the skepticism and the real science and the real space tracks over here are wildly popular. We're drawing people in like crazy. I think the only reason, look how many people there are in here. This is 10 a.m. Monday morning, last day of the con, everybody's hungover, right? And you're here. You bet there's reason to hope.
Kylie, the question you asked is really about the future of skepticism. You look at not only these indications that there's a bright future, but technology is opening doors. I'm very excited about what Martin was talking about, the syllabus that you have. At campusinquirer.org, we have a collection of about 80 high school and college students' syllabi that are teaching critical thinking and skepticism. And if yours isn't up there, we'd love to feature it because it's that kind of thing. Then we want more professors doing this sort of stuff. Lastly, I just mentioned technology. The kudo emails we get, the group of people we get most of them from are college students who didn't know such a movement existed. They don't subscribe to magazines. They don't go to conventions. They say, "Oh wow, I felt like I was the lone critical thinker, in this big sea of the credulous." And frankly, a lot of time it has to do with free thinking versus kind of religious extremism, but CFI's agenda is broader than that. So we're reaching out like we never have before. I think there's a brighter future than there has been a glorious past in the organized skeptical movement. And there have been some good old days, 20 years ago. So I'm only optimistic.
Just on a final point about technology, all of us have embraced technology. Two of us here are podcasters, Skeptic Zone podcast and Point of Inquiry. We have the criticalteaching.org site where you can access the blogs of myself, Barbara and Matt, and Martin is at Griffith University, and you can certainly find links to his course there, and we're all available to talk to anyone, and that's what we're going to do now, I guess. Terry, any questions?
To learn more, you can head to Griffith University for Dr. Bridgstock's course, which will soon be available as an external study unit. His book is called Beyond Belief, Skepticism, Science and the Paranormal. Members of the Critical Thinking Education Group can be found at criticalteaching.org, with Barbara Drescher and Matt Lowry's blogs called icbseverywhere.com and skepticalteacher.wordpress.com. DJ Grothe is at djgrothe.com, and at the JREF official site, my blog is podblackcat at podblack.com.
Crikey! This is Richard Saunders from Down Under, former telly-celebrity, current podcaster, and future bushranger. I'm coming all the way across the pond to visit you Yanks in California to tell you all about my favourite podcast, Skeptoid. I'm also going to introduce you to Foster's Beer. I'll yabber on about all sorts of things, and we may even have a yarn. So I hope you all lob in with your ears flapping. Skeptics in the Pub, hosted by Skeptics in the OC. Saturday, 2nd of January 2010 at 19 o'clock. That's 7 p.m. for you yobbos. At Muldoon's Irish Pub in Newport Beach, California. Join me for a pot of liquid amber. Hooroo!
And now we jump in our Skeptic Zone time machine back to 1988 to hear Dr. David Wheeler talking about crystal power and pyramids. And immediately after that, we have Professor Ian Plimer, geologist, and Magda Palmer, crystal believer, whatever, talking about the power of crystals. I think you'll enjoy that one.
Our third speaker for this session is Dr. David Wheeler, a physicist lecturer at the St. George College of TAFE, who will talk on crystals and pyramid power. Thank you very much.
To begin with, I should really point out the three areas I've got are really crystals, crystal healing and pyramid power. And they do share a common feature, and the common feature is that they all claim to use energy and to redirect it, which is why as a physicist I'm interested in it. Physicists have a basic belief, and the basic belief from evidence is that the total energy in the universe is a constant. Now, what sort of thing do we mean by this energy? And this is really where part of the problem occurs. We've got a really simple definition, but it sounds technical. It says anything that can do work, where work's defined as force times distance, and that's sort of mathematical. What it means in real terms is things like chemical energy, which you're all familiar with as cornflakes and batteries and things like that. Visible energy, such as light. Sound, heat. Motion, such as anything moving, will have some energy, e.g. try tackling Noel Clearle and you'll see what I mean. Potential energy, such as gravitational or elastic energy. And the one that's fairly recent, which is nuclear energy. But we've never really come across pyramid or crystal energy, ever. That doesn't mean it doesn't exist, and I think it's important to realise that it could exist. I mean, relativity, for example, didn't exist pre-1900, and then suddenly it does, and we now have the extra energy, the nuclear energy. But the big thing is, and this is what makes the difference, extraordinary claims need extraordinary evidence. Relativity was an extraordinary claim, and it was achieved with some extraordinary evidence. So really what we've got to do now is go a bit further and look at the crystal system and see whether there's anything there that is good evidence and possibly even worth making into extraordinary evidence. I'm going to refer to a book. This is a photocopy of the book. It's a book called Natural Quartz Healing Crystals, and it was sent to skeptics by Simon Sanborn, who's apparently from Melbourne. I haven't met Simon, but it's a top book. It is a book that the people who put out the crystals think describes what crystals do. For example, at the beginning of it, right on the first page, it says this little line: quartz amplifies, transforms, stores, focuses, and transfers energy. Okay, let's have a look at that. Quartz crystals are just silicon dioxide. They're nothing particularly stunning. Do they amplify? No. Do they transform energy? No. Do they store energy? Sort of. If you get any material, it does transform energy. Whether you can use it, that depends. Do they focus energy? No. And do they heal? No. And when I say no, I'm saying that's what traditional science says. That's what conventional science says. Doesn't mean that they don't, but it means that if they do, the evidence so far has been so slight and so minimal that nobody's actually seen it. So let's begin with the first two. I'm only going to really deal with the first two because they're the ones that the New Agers get excited about. Amplification, for instance. Do these things amplify? The short answer is no, and the confusion here is with crystal sets and transistors. In fact, even in this book, they begin by pointing out that silicon in a transistor amplifies. There's a slight problem here. Silicon is not silicon dioxide, but more about that in a sec. The difference between the two things, between the silicon dioxide and the silicon, is the nature of the material. Silicon dioxide is this. This is a poor quality chunk of quartz, which you can have a look at later. It's not crystal clear, it's still a crystal. And that's the way it often occurs. On the other hand, silicon is a material that's an element. It looks very much like, I guess, the lead in HB pencils. It's a similar sort of stuff to that. It's closely related to carbon rather than related to silicon dioxide. But it's the sort of thing that we make our transistors out of. So the first point is that transistors are not made out of silicon dioxide. They're not made out of quartz. The second point is that crystal sets, which is one of the big confusions, do absorb energy. There's no question about that. Anyone who's played with a crystal set knows that. But it's not the crystal that absorbs the energy, it's the aerial. And this is a point that the New Agers seem to have missed. Crystal sets have aerials which are in general very, very long so that a lot of energy can be absorbed, sort of like glass vibrating. When you make a loud sound, you can make glass vibrate. And that's an effect known as resonance. It's a well-known effect. It's how we tune our radios. It's how we can distinguish 2SM from 2WS, even though they're very close together in frequency. And all the crystal does is rectify. It's sort of like a crude diode or a one-way valve. The crystal doesn't absorb on its own. It just simply acts as this one-way valve. The energy in the crystal set comes from the radio station, and the stuff that's actually used is in the crystal set is a stuff called galena. That's this one, which is much less impressive. It's black and it's got little bits all over it. The little crystals all over it are simply used because when you put a fine point up against them, you can find some areas which behave as semiconductors. You've got to remember when crystal sets came out, we didn't have semiconductors and transistor radios like we've got now, largely because we didn't know about the effects. Radio waves with energy from the station oscillate, because that's what they're all about, hit the aerial and cause the oscillations in the aerial. And these in turn can give you the sound or whatever you're going to get out of it. The absorbed energy is then transferred to the speakers, that's the headphones, after passing through the crystal, which acts as a filter. The crystal doesn't add energy, that's the key. It doesn't add energy. It just converts the signal by cutting off the AC and changing it to DC so your audio can be removed. And it's really not the crystal itself that does it, it's a crystal junction. It's the boundary between where the crystal is and the little point that touched onto it. That was what they were all about. And when we say then, since it doesn't actually absorb energy, it does the crystal itself, does it transform it? Well, your answer to that is sometimes. Sometimes a crystal can transform energy because when you add energy to anything, it'll obviously transform it. I mean, for instance, you transform energy when you eat your cornflakes because you transform the chemical energy into sound energy, heat energy, motion energy, and so on. So in that sense, I guess they're a little bit right. The crystal book is an amazing mixture of science fact, science fiction, and just plain confusion. I took out another little section of it, which happens to also be on the front page, and it says this: quartz transforms energy. If squeezed, it generates electricity. That's actually partially true. As you'll see in a couple of seconds, you can do that, but not quite the way they think. When an electrical current is sent through it, it swells. That's also true. An alternating current causes it to alternatively swell and shrink. Done fast enough, this is called oscillation. That's interesting. Done fast enough is of the order of millions of times a second, which leads to some interesting possibilities if you're going to use crystals in the way New Agers do. When cut in precise shapes, quartz vibrates at precise rates and transforms electricity into waves which can be broadcast. That's not entirely true. Quartz changes solar energy into electricity in devices called photovoltaic cells. That is rubbish. Photovoltaic cells are not quartz crystals, they're special p-n junction materials. But what are they talking about here? What's the science of it? Because really that's what you should know. If you're going to talk to anyone who's into crystals, you need to know a little bit about what the real facts are. The real facts are that they use an effect, which Peter mentioned earlier, called piezoelectricity, which simply means press it and you get an electric current. What you do is if you roll the crystal under a strong enough electric field, you can align the dipoles and then you compress it, preferably very quickly, and the result is you get a voltage. Now the basic idea is you grab the crystal and slam the ends of it. There are a couple of points about this. The first thing is rapid hitting is best. You've got to go slam very quickly. You can't do this just casually hanging onto a crystal. You have to get it, slam it really hard, and you've got to have some sort of circuit set up because one end goes positive, one end goes negative, and the only way you're going to feel anything is if you've got a circuit. The New Agers are okay here because they can grab the crystal and they make the circuit all the way round. The trouble is that what you're doing is you're basically setting up a very high voltage and a very small current, so you're not likely to feel too much unless you can do it incredibly quickly. Now some natural crystals, for example silicon dioxide, are piezoelectric, but the big negative with that material, with quartz, the big negative is that it's piezoelectric but only very, very little bit. Why is it used so much? Well, the answer is it's not temperature dependent like a lot of the other materials are. You can use natural Rochelle salts. They don't look as good, but you can use them if you want. If you really want a big buzz from crystals and you're really into it in a big way, what you should do is get either lead zirconate or barium titanate. Now, barium titanate was discovered in 1940, so it's not as if the New Agers had to wait till now to get it. What you do is you heat a mixture containing various salts in an oven in an electric field and you produce this ceramic. Problem with ceramics is they're black. These particular ceramics, they're black and they're unlovely. They're sort of like ferrites, the cores of transformers. And the trouble with that is that people don't really like to sort of walk around with this big black yucky looking thing. They like crystals that look really nice. So that's why they're probably not used. If you're really into it in a big way and you want a really big buzz, you'd use a plastic. Not an ordinary everyday plastic, but you'd go to somewhere like Plessy and you'd have a chat with them and say, can we have your plastics that you use in the, for example, super microphones for the submarines? Anyone who read The Australian last week would notice there was an article about how the submarines cruise around detecting when the say Russian subs open their doors to remove, say, anything, when they want to throw rubbish out. The American subs can hear it because they trail these giant microphones, and they're made of that special plastic. These things under hand pressure can give you about 50,000 volts applying microamps, so you'd really get a buzz out of that. But the trouble is, you'd have to keep going like that. Now, you might like to think about this. Imagine a new ager who gets a crystal, grabs a crystal, and normally what they do, they hold it because they love their crystals. They don't get their crystals and strangle them, you know. Imagine someone sitting in a train. What would you think? I mean, you know, it wouldn't be the most calming, relaxing thing. And in any case, it's not going to give you a big buzz. If you want, you can squeeze some of these later and you won't get too much. If you would like a buzz, though, this one. Now, you can't see the crystal in here without pulling it apart. This is a commercial spark generator. All you do is you hold that and press it down. And if that end is anywhere near something that's earthed, then the voltage can discharge and you'll get a spark, about 25,000 volts. If anybody wants to feel that later, it's no problem. You just sort of put your hand in the way and I'll press the button. And that's using the piezoelectric effect. But the key is, and I'll just do it once here and show you what happens. You've got to press it like that. I got that because the edge of this isn't so well insulated. So I don't like doing this heaps of times. But what happens is, as you press that through, the arrangement inside is designed to go pounce once, and that's it. So if you're going to get the effect, you've really got to go like that to get it properly. They don't tend to do that. What's important is that the time between the bangs, like that, is really quick, and then you get the nice buzz, but it's sort of like hitting a jelly with, imagine a jelly, an upside down jelly, and you hit it with a spoon and the thing vibrates. That's what's actually happening. So when the new agers tell you that these things do it, they do, but under special conditions. Watch them. If they're standing there going like this, there's a vague chance they're probably getting millivolts or something. If they're getting the sort of buzz that we get out of this one, you'd also know that too, but that would be in commercial quantities. So the basic clue is, if they do get anything at all, it's not observable to modern science as we know it. So maybe they get something else. Maybe they're special people that get something else. Well, if so, the only way we can really find out is to get them and sort of study them while they're doing it. Certainly the effects they claim to work, and this is really my point on it, the effects they claim, that is that it's like transistor radios, that it's like using a crystal set, those effects definitely are not true. If they do get anything out of it, the excuses they give, the explanations they give are not right, because they don't go through those sort of effects. The book's got heaps and heaps of other falsehoods like that, including the bit that I think's dangerous, and that's the one Peter did earlier, about holding the crystal and getting the energy out of the air. Now you'll notice just the way he did that. He had one hand up and he's holding the crystal. Actually, it was this hand up, wasn't it? One hand up and he's holding the hand over the part with the crystal to focus the energy in. What does that look like? It looks very much like an aerial running onto a crystal set. You know, the crystal represents a crystal set. There's the aerial. As we just pointed out, or as I pointed out a little earlier, the crystal set only works because you've got a really long aerial absorbing energy from the radio or whatever else. If people, by doing that, absorbed energy and the crystal focuses it, then every time you do that, you absorb energy anyway. And if you think about it, kids in class every day must create a hell of a lot of energy every time they put their hand up. Right? So if you get a kid, if you're a teacher and you get a kid in a primary school or something, he says, "Can I leave the room?" And you say no, and he does it again. What? And Nazis, heaps. Nazis would have generated heaps and heaps of it, because it would have absorbed into them and presumably then focused the energy somewhere, wherever their other hand were. Think about things like, you know, it would depend very heavily on where this hand was, and if you happen to have anything crystal in it, you could have a real problem. Now, part of the argument, of course, is that they focus it because of their shape, but, you know, again, that's arguable. What is the energy? Where did it come from? We don't know in science, and we'd love to know. It would be really nice. I mean, you know, you could do wonderful things. As for the pyramid power, I'm only going to give that passing coverage because the evidence here is even sloppier. The claims are harder to unify because they go from everything from sharpening razor blades to prevention of decay of organisms to increasing the decay of organisms. Now, that's a bit of a problem, you know, when it improves some things and deteriorates others. I thought probably the easiest thing to show you with that was a little quote from Skeptical Inquirer. In the Skeptical Inquirer, the last edition that came out, there's a little article in it about putting French wines to the pyramid test. And apparently, I'll just read quickly a couple of sections. Some small-scale models of pyramids are supposed to generate form waves which, although unknown to physicists, can preserve meat, sharpen old razor blades and even cure cancer. A big plexiglass model of the Great Pyramid was set up by Pierre di Carello, a well-known specialist in pyramidology. 7 bottles of wine less than 2 years old were placed inside the model. And the idea was, at the end of this particular fair that was going on, they would demonstrate that these wines were actually better than the wines which were put aside as a test group. Now, what actually happened in this was that the test group of wines put aside were stored in the office of the guy actually running the show. So they weren't refrigerated, they were just stored away there. At the end, when they did the test, the pyramid wines came out in front, but only just in front, only with red wine, so they was too weak to have any meaningful significance, and if it had, it would not have been favourable to the pyramid. The red wines kept in the pyramid were only slightly less than the control wines. Such a difference was basically obviously due to chance. So how did it happen that the result of the first experiment was favourable to the wine from the pyramid? The answer is simple. It was because of the bottles of champagne. Those coming from the pyramid had a tolerable result, a 2.4 average out of 4 by testers. The 2 control bottles of champagne had a much lower score of 1.7. Such probability being due to chance would be about 1 in 9 million. So what was the explanation? The explanation could probably be found in the differences of temperature and air circulating between the pyramid and the President's cosy office. It was not that the pyramid champagne had improved, but rather the control champagne had got worse. The scientific lesson of all this is that 1, pyramid models have no influence on any kind of wine, and 2, for those who may not know it, champagne must be kept cool and served icy. Now, what's significant about that is that was actually a pretty reasonable test. I should finish by saying that it seems to me then that crystals, and apparently pyramids, don't fit what we already know about energy. For those of you who like to subscribe to these sort of things, Peter showed me this one last night. This is Nexus, which costs $2.50. And in this particular issue, there's lots of ads for things like crystal dreaming. Your dream is a crystal's desire. So you can buy these crystals from a place at Clareville. Crystal Light, which says call for a magical visit. And they sort of go on with heaps of these. But the one that I particularly liked out of this is a place called the Quartz Crystal Awareness Centre. Now, the Quartz Crystal Awareness Centre is moving to Bellingen. And they're opening, in fact, they've already opened. The ad says, opening 1st of April 1988. I thought that was pretty appropriate. What we get from the New Agers, who are into these things basically, is a mixture of misunderstanding, confusion and wishful thinking. I'd sort of like to say it to them as a physicist. If they can demonstrate that they, or their crystals, or their pyramids, can do what they say they can do, nothing more, just what they say they can do. We're not asking for anything amazing. Just show that the crystals can amplify or create energy. Then conventional science will be very interested and we'd give them a hearing. Until then, the verdict is the same as that pronounced on the other pseudosciences, and that is, sounds nice, pity it doesn't work. Thank you.
Since time began, man has been fascinated with crystals and precious stones. The way in which these stones bend, reflect and refract light into the colours of the rainbow suggested to many that crystals had an energy of their own, that they even had magical and mystical qualities. Healing powers were attributed to certain crystals, and stones such as quartz, amethyst and emerald were said to heal specific complaints. 10 years ago, even 5 years ago, you wouldn't have heard anyone other than scientists or gemologists talking excitedly about crystals. But today, the ancient beliefs in the power of crystals have been revived. An increasing number of Australians will produce a crystal from their pocket or handbag and extol its virtues. They induce calm, help with sleep, improve sex life, and aid personal transformations. They purify water and are reputed as having special healing powers. Magda, a crystal consultant, has spent the last 9 years researching gemstones and has published her findings in The Healing Power of Crystals. Plimer has had a lifelong interest in minerals and their crystals and is a professor of geology and head of the geology department at Newcastle University. He's also a member of Australian Skeptics and recently slammed what he calls an irresponsible New Age belief. Well, Magda, first to you. You've written this book, The Healing Power of Crystals. But before we talk about crystals and healing, I'd like to talk about them in a wider context first. Do you believe crystals have inherent power?
Yes, I do, even if it was only taken from its beauty.
Do you believe crystals vibrate by themselves?
Well, they do. It's been proven scientifically. They actually start, well, little... Hang on, I don't like this word vibrate because it conjures up to the layman a boom, 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 boom. That's not quite right, really.
But do crystals have an inherent energy?
Yes, and that energy does come out in the form of little vibrations which start about room temperature and above.
I want to ask you if crystals are a conduit to a greater form of power.
Yes, they are.
What is that power?
The power is bringing out your intuition more than anything else. And it's also acting as an amplifying energy to all types of medicinals.
So a belief in crystals for you is part of a greater belief system?
Part of a much greater belief system. It's a belief in light, the life force itself, in teaching people the beauty of our Earth. Why look out to space? We didn't even see, for a start, our own Earth until man stepped off into space and looked back. And then he saw this blue globe that was our life itself. And that's what, then again, the crystal thing started coming up. This belief in crystals, right, something is in our Earth. Is it crystals? And they look back to ancient times, and that hit at the same time as the drug market had become so overblown that people were tired of
Well,
it.
if you believe that crystals have particular powers then, do you then treat crystals with a particular reverence?
Oh, yes, but I treat everything beautiful with reverence, and the
Is the
non-beauty
sort of
as
reverence
well.
you attach to crystals the reverence of something that Christians would call holy?
I won't come into a religious thing at all. I believe all religions should be one. And if religions must exist, then for heaven's sake, let them start knitting. But no, it's not a cult thing at all.
Let's talk about crystals and healing.
Yep.
What do you believe a crystal can do in the healing process?
We never say the word healing. Actually, we say stabilizing.
You call your book The Healing Power of Crystals.
That's right. That's because healing is referred to in many ways, such as healing the earth is planting a lot more trees in it. There you're healing the earth. Right, you can heal all sorts of things. A doctor says they heal, but in reality, everything that you only do in healing medically is stabilizing.
What are crystals able to do in the healing process? What experiments do you know of that prove that crystals may do some?
I had a wonderful thing. I worked with groups, you see, it was group control I was working with in Britain, that took in America as well as Holland and England and Scotland. And the north of England had an MS, multiple sclerosis group working, and I thought, oh no, don't give me these people. It's too tragic and there's nothing we can do. And that was my thought. And of course I have learned, which is very important when you start dealing with crystals and crystal people, they learn to bring this out in you, be positive about everything. So I thought, fine, we'll try this. So I gave them crystals. It was group control, meaning the group of people were not allowed to use anything other than the crystals suggested. We went through quartz crystal. It seemed to make them have more pain, more worry. After many, we got them to lapis lazuli, which is this beautiful blue one here, and we got them to tourmaline. Now, tourmaline is a stone, it's a crystal, and it's usually a precious crystal, has many colours, it has a lot of energy, and it's...
So you feel personally satisfied that crystals certainly help in the healing process?
Stabilise the MS people.
Ian, you're a geologist, you work with crystals just about every day of the week. Do you believe that crystals have any special powers?
Well, as a professor of geology and having worked on minerals and crystals for 25 years, I view it the same as I view many other New Age phenomena, is rather deluded people leading a mob of ignorant people.
But we value crystals in technology today.
That's crystals where we actually put energy into a crystal and we get energy out. The very fact that this transmission is occurring is because of that. But there are some very interesting things in her book about the energy of crystals. One of the crystals I have here is a crystal of quartz. And in the back of the book, there's an appendix that tells us various treatments that we can use minerals for. And we're told that this crystal can be used to treat all sorts of ailments. And the one that really fascinates me is kennel cough in dogs.
You've written about kennel cough?
And the problem with the book is that we don't quite know how to administer it. And really the only way I can think of administering this crystal to a dog that's got kennel cough is to wait until he coughs and shove it down the dog's throat. Then he'll never cough again. Well, this one here, this crystal here, now this one here is promoted as being a crystal which will solve an ailment which has really been afflicting mankind for a very long period of time. The problem is this crystal has very recently been discovered. It's a type of garnet, it's uvarovite, and it's meant to be used for the treatment of flatulence. Now, I've had these crystals for some 20 years, and madam, it hasn't helped.
Maybe you're throwing it down your throat as you would the dog with kennel cough. Oh, no. You've said you read my book, Ian. You haven't read it.
There are some other areas in the book which interested me. I think there are some areas which are bordering on being very irresponsible. There is one crystal like this. You promote this on page 148, and you say it should be used for the treatment of a venomous bite. Now, I think that is irresponsible to claim that crystals of native sulphur can be used to treat a venomous bite. If you have a venomous bite, you don't hold this crystal and hum or tune it or feel the aura while your life is ebbing away. You go to hospital. So I think it's very irresponsible to write that crystals can be used to treat a venomous bite, or in the case of this crystal here, to treat cholera. Cholera can be treated very easily.
So
but not by crystals.
I'd like to actually take him up there because actually you've done something very silly. What you've actually done, Ian, is mention little parts of the book and said you've read the whole thing. If you'd have read the whole thing, you'd say that you'd actually be able to say that I have carefully written that all alternative medicine, including crystal healing, should actually be used with an orthodox medic as well. They should all be combined.
The appendix on page 148 says that they should be used for the treatment of these diseases or afflictions.
What you've done, for some reason or other, is just being vindictive about something that is quite silly, and you're calling it... First of all, let's go back to your first mistake. Your first mistake was New Age. This is not New Age. And have I said New Age at any stage? No. Nobody has. For a start, crystal healing and the power of crystals, and in fact all alternative medicine, was here way before the orthodox medics brought in drugs. Would you actually consider that somebody with intelligence that I'm sure must have been easily as great as yours would actually list something like this, Pliny, for instance, as being a healing crystal?
Madam, you have also listed a number of crystals there that have just been found. Now, Pliny is a very good one. Pliny,
of course I have.
Records the fact that
this man is actually
talking
this
about
crystal
Pliny
amethyst.
because most of us don't know what Pliny is, but I think it's worth asking.
Ian is saying some very silly things, such as the crystal that's just listed. You'll find that there are crystals that are not just listed too, very ancient ones.
Right. I think
it's just been found.
I think it's worth asking.
He's picking things out to try and make a fool of the whole thing.
In looking at crystals, is crystals a harmless pursuit? Would you say that you're not doing any harm to anybody in following a belief in crystals?
Well, if you had somebody as, dare I say, as silly as Ian, who would throw a crystal down his dog's throat, or who would crush it, when my book actually says you do not crush crystals. It actually says that quite clearly. Because otherwise we would be sued.
I think you missed the point. That crystal here is not mentioned in your book. I'm just showing that anyone can make up all sorts of gobbledygook.
Please, sir, let me have my say.
And you can search the cosmos for delusion, and you are selling this gobbledygook to people.
Okay, you've had plenty to say.
Let's take this into a wider context.
Yes, but I would like to finish what I was just saying, Angela, about you said if they can harm. Certainly if you had somebody who did something as silly as Ian did, but crystal people don't do that.
So you're not advocating doing that?
No, and it says clearly in the book not to do that, actually.
Well, let's take a wider context here and say that is there any harm in looking at a crystal for a healing process as opposed to, say, drinking water from Lourdes? I mean, Catholics very happily drink water from Lourdes. Some Catholics would.
The problem with crystals is that people are touting their ignorance. Crystals are natural chemicals, very simple. We can explain all their properties with schoolboy physics and chemistry. I've got 3 crystals here. Mm-hmm. You lay your hands on them and tell me what you would use them for, or what energies you feel, or what powers you're getting from them. These are crystals you've written about in your book. You clearly are aware of the sort of energies and powers. Now, you tell me what is coming from those crystals. You can touch them or fondle them or tune them or whatever gobbledygook you want to use. But you tell me and we'll check it in your book.
First of all, I'd like to object to you using the word gobbledygook.
Just do the experiment.
And secondly,
let us see whether it works.
Will you
Just do the
please
experiment.
be quiet and let me speak? You're quite silly. You're not even being ruthless.
Just do the
It's
experiment.
unbelievable. What you should really be doing here is not saying that and that. You feel this, you feel that. Because whatever happens, you're going to go in on an attack. You're not ready to even learn. You're the type of man who doesn't bring the
Madam,
world
you are
forward.
a sham.
So
you are not prepared
Hang on,
to
Ian,
demonstrate
you're not
your
prepared
art.
to do this experiment.
Not with him here, the way he does it. I'm willing to bring a doctor on. I'm willing to bring people who've actually recipients.
How much interest actually is there in the community?
There's a huge amount, but I haven't come onto the programme to simply be attacked and be called names. I've come onto the programme hoping that we might be able to do something with somebody who wouldn't open their mind to anything.
Do you think Ian's beyond help?
Nobody is. Not even Ian. He's beyond help as long as he keeps attacking and won't actually open his mind to anything. And I think a crystal could help him to do it, and I've brought one to help him.
Madam, I have been dealing with crystals for 25 years. I understand their physics very clearly. I understand their chemistry very clearly. You just do a simple little experiment to show that what you're saying actually works. You don't like that experiment?
But
I can
why
give you
should
another one if you like.
No, hang on. I'm not going to
Just
be
demonstrate
debased like
that
this.
you
Ian,
get something.
however, if people believe that if people draw some sort of comfort from crystals, why burst their warm little bubbles?
Except that it is being promoted, as in this book, that they can be used for the treatment of certain illnesses. And the second thing is that part of the wonderful crystal collecting areas in this country are being absolutely destroyed.
Just
and
a
part of
final
our
question,
national
Magda.
state is being destroyed.
Magda, do you have people working solely from your book as a way of trying to heal themselves?
No. And I send them to doctors as well. I send them to psychiatrists. I have doctors coming to me, medical doctors coming. I have psychiatrists, psychologists. We have a great range of people, and they don't just work from my book. I could actually say, yes, well, I took gemology at London City Poly. I can say this, and I can say, yes, I've been working with crystals for many, many years too, and I've been holding them from a child. From a tiny little child, I learned to hold an amethyst to get me through exams.
But you still haven't been able to get any energy from these three crystals which you write about. And until you can demonstrate it works, you are a sham.
I think we'll have to leave it there. Thank you both very much for coming in, Magda, and also Ian Plimer. Thank you for your time today.
Thank you for joining me for this episode of the Skeptic Zone. Another one in our summer series, that's if you're in Australia, or winter series if you're in the United States, coming up next week on the 8th of January. The full show gets back into gear on the 15th of January, and we'll try to get a think tank going for that one. Until next week, anyway, this is Richard Saunders signing off.
You've been listening to The Skeptic Zone. Visit our website at www.skepticzone.tv for comments, contacts, and extra video reports.